morning, guys. My name is Jake Hawkins, and this is my brand new and used car lot. I sell a lot of new and used cars, and it's a new business, and I'm just here to get it rolling. Now I'm back in my new office, but I just realized I have all these cars that I need to put into my computer. I need to log their information, but I don't have any kind of programs to do it. Thanks to AP Computer Science, it taught me how to make different classes so that I can store different information.
So now I'm going to teach you guys about classes, the different kinds of classes, and the base formats for classes that we use. So the first thing you're going to want to do in this instance is we're going to create our car class, which is going to be used, and we're going to set up these private instance variables. So for a car, two of the most basic things you're going to need are its make, or like its brand, and the year the car was made. So we make these instance variables private so they can only be accessed by the class itself. So the next thing we're going to want to do is make a public constructor. So your constructor has to be the same name as the class that you just made. So for this instance, it'll be car. So within this constructor, we're just going to initialize the make and the year to just something blank, as there are no parameters in this method. So make and year. So the point of calling this method here would just be to create a car object that really doesn't hold anything yet. So then you can also create another constructor. So this constructor will hold two parameters. So it'll hold string m for model and an int y for years. So in this method, we're going to initialize make to whatever's put in the m parameter and year to whatever's put in the y parameter. So this allows the user to call this method, and it's going to create a car object, and it's automatically going to initialize the make and the year of the car. So this just makes it a lot easier than going through this process. So after you make your two constructors, you're going to create what we call accessors. So accessors, you always want to comment your code so that anyone that's reading your code can see what you're doing a lot easier. So in your accessors, we're going to create different ways that you can call a car object to return either the make or the year in this case. So the first method we're going to make is public string get make. So the point of this method would be to call whatever the make of a certain car is. So return make. It's pretty easy. So then we're going to make another one for our year. Get year. And what this is going to do is return the year to the user. So that's pretty much it for accessors. They're pretty basic. They're just used to gather information from an object that you've already created. So if you do something in our basic constructor, if you call this method getMake, it won't return anything. If you return getYear, it'll just return 0. So along with accessors, we have what are called mutators. So what a mutator does is the opposite of an accessor. Mutators allow you to set an instance variable for whatever object you want and however you want to do it. So these are also oftentimes called setters. You don't hear it a lot, but you do hear it some. So let's say we want to make a setter for the make. So we do public void, because we're not returning anything, set make with the string m parameter. So all this method does is allows you to reinitialize m to make. Ooh. So then we can do the same thing with our year. So public void set year int y. And all these two methods allow you to do is, so let's say we create just with our base parameter a new car object. So it doesn't have a make and it doesn't have a year yet. So we can use these two methods to set the make and the year ourselves instead of doing it with the parameters. Or if you do call the constructor with the two parameters, you can then edit the make and the year using these two methods. So another thing that you're going to want to have in your class is a toString method. So the toString method just allows you to print out pretty much all the information that you would need on whatever's in your class. So in this instance, it's about cars. So we're going to do public string toString. In this case, we're going to want to have this method return the make and the year of whatever car it is. So return the make the year So then anytime this method here is called, it'll return the make and the year of the car. It'll just print it out for you. So that makes it really easy just to get everything you would need from the car class. But this here is our base class that we would normally use. So in each class, you're going to want to have your instance variables. You're going to want to have two constructors, a basic one that has no parameters, and then one that does have parameters. Then you're going to want to have your accessors that allow you to gather your instance variables from the class. Then you're going to want to have your mutators that allow you to edit your instance variables from the class. And then you're always going to want to have a toString method that just easily allows you to print out whatever you need. Now, one thing I did mess up on the last part of the video is your class name and your constructor should all start with a capital letter. So in this case, capital C in car. So I did mess that up on the last part of the video, so I'm sorry about that. Okay, but now I've created a tester class to show you how all these new methods can work. So I've created a car object racer with the two parameters and a car object speedster without any parameters. So I'm going to show you guys what happens when we call the toString method of the racer. So it should print out the make and the year. So compile, call it, and it should be right here. So we have the make and the year right here. Now let's see what happens if we call the speedster toString. You should see that it wouldn't really come up with, it'll show the make, but it won't give an actual make, and it'll just put the year at 0. File, and there we go. So that shows us that without putting any parameters in, it doesn't really initialize. It initializes the speedster to just whatever your default is. So now I'm going to show you guys what the setters can do for speedster. So let's do speedster dot set make to forward, and then let's do the speedster dot set year to 2005. Now we'll compile this and call back the tester. And there we go. So it initialized the make to forward and the year to 2005, just like we thought it would. So now I'm going to show you guys how we can use our accessors or our getters. So let's say we want to just see the make of speedster. So we would do speedster dot get make, and you have to make sure you do the system.out.print. You can't just call this by itself to print it out. So we compile it, run it, and you'll see that we just got forward. And we can do the same thing with get year. Compile, call it. We got 2005 just like we thought we would. The next thing we're going to talk about are subclasses, or classes that extend a parent class. So in this case, I've created the subclass specs, which gives extra specifications to our original car class. So to make a subclass, in your class declaration, you're going to want to do public, class, whatever the name of your new class is, extends whatever the parent class is, which in this case is car. And then you're going to want to go on through and do your same instance variables, have your accessors, mutators, a toString method. What's very different in your subclass is how you do your constructors. Because even in the subclass, you're still going to want to initialize the instance variables that are in the parent class. So Java gives a very easy way to do this, which is the super method. By calling super, it initializes whatever these instance variables are by calling the constructor, your base constructor, depending on if you put the parameters in here. So after we do super, we go on through and do what we would normally do in our first constructor. So we would initialize model just to something blank, just to give it an initialization, and same with price. So then on our second constructor, we're actually going to want to give it 4 parameters. 2 for these instance variables of the parent class, and 2 for our extended class, our subclass. So we'll do string m for model, int y for year, string md for model, and int p for price, which we just made. So then whenever we come down here, we're going to want to call the super method, but this time we're actually going to put in the m and y for its parameters, which allows us to initialize these 2 instance variables by calling this constructor with the 2 parameters. So then after we do this, we'll do what we normally do. So model will be set to MD, and then price will be set to P. So it's really pretty simple. Well, you just have to remember to do the super method, so you initialize the original instance variables of the parent class. So then down here on our toString method, we'll change that up too. So we need, if we still want to return the instance variables from our parent class, whenever we do our return statement, if we want to put in, let's say, the make, we're going to do plus super, which is this original class, dot get make. So if we do that, it'll call the get make method from the parent class. So we can then go on through and do the same thing with the model. So model plus super. Oh, nope. Model is what we just created, so model would just be plus model, because that's an instance variable within the subclass. And then we can do plus, let's do year. And then on that we would do super dot get year. I can come down here and then do plus our price, which we just created with this subclass, plus price. So then whenever we run the tester class, it'll call all these methods as well. So now what we're going to do is, now we'll compile it. Oh, simple little error. Recompile. What did I do here? Oh, forgot to put the parentheses right here. Sorry about that. Now it should compile. There we go. So I just created a tester class to test the subclass that we just created. So to create an object from your subclass, you just do the subclass equals, initialize it to a new subclass, so specs s equals new specs, and do however many parameters you want, or you can just leave it blank, leave the parameters blank and just do your base constructor. Or what you can do is create a new car object from your parent class, initialize that to be for a new specs, and do however many parameters that you need. However, what you cannot do is do a subclass, or create a subclass object and initialize it to your parent class. This always throws an error, so make sure you never do that. So what I'm going to show you now is that a subclass can really do just as much as any other class can. So we can call our toString method just like we would with anything else. Compile that. Let's run it. And we can see make Ford model Mustang, year 1997, and price $12,000, just like we initialized up here with our parameters. We can also, even though it's a subclass, we can still use all the methods from the parent class. So I'll show you that. So let's say we do s.set year to 1920. So 1920. So if we do that, recompile it, if we reprint it, we can see that it changes the year to 1920. So you can really call any methods from your parent class or any methods from your subclass. So we can do the methods that we just did for our subclass as well. So set price to $1,920. So if we run that, see that it changed the price. The next type of classes we're going to talk about briefly are interfaces. Interfaces are used to put method signatures in, and any kind of class you use that implements an interface has to contain and define all of the method signatures listed in the interface. So for example for this is I used the specs class that we used earlier, but you change your declaration to public class name implements whatever your interface is. So for this one it's car2. So I took out all the super methods in our toString. I took out all the things from the car class, our original car class, just to make this easier for the sake of the video. So if I compile both of these, both compile because all of the methods listed in here are put in here. Now let's say I create a new method, void set make string m, that's not listed in the class that we just created. If I compile this, it won't compile because it doesn't define the method set make that's given in our interface. So interfaces are a great way just to be able to easily see all the methods that are in your classes. So, and then it's just a good way just to be able to implement all those methods easily into your subclasses. So here's an overview of all the topics that we just covered. So we covered a basic class. It should contain at least 2 constructors, one without parameters, and then one containing parameters. You should have your accessors, which allow you to pull and have a return value for any of your instance variables. You should have mutators, which allow you to change your instance variables. A toString method isn't always needed, but depending on whatever kind of class you use, it is a very helpful method to have. And then you can include anything else you may need. I didn't really go over too many void methods, but you can make a lot of void methods that do different algorithms and calculate whatever you need, print out anything you need. I mean, you can really do anything with these other methods. With subclasses, they always need to extend a parent class. It's always good to use a super method in your constructors because then it calls the parent class, and you can, just like with the regular class, you can add anything else you may need. We also briefly went over interfaces, which contain only method signatures, and the classes that implement them must define all the method signatures, and they're used mainly to specify a behavior that a class implements.
Thanks to AP Computer Science, I was able to make some pretty awesome classes that allowed me to store information about my new and used cars. Thanks, AP Computer Science.